Hello, this is Dr. Hassan Abdullah with the course Web Applications Programming. And the topic which we are covering is SQL programming or structured query language programming. And this is topic number 7 in our list of topics of the course. And this topic has the subtopic D, which is 7D. And in this 7D, we will be covering nested queries. Nested queries means that there is a query, and within that query, there is another query running. Learning management system, and it has some wonderful features which facilitate and which help you get the most out of it. So it provides full text search, basic and advanced, and you can search for the topics or the material of your interest. And if there is any visual disability, the user can set the font size, the color, the line spacing, the type of font to facilitate to maximize. And the content is displayed and is presented in a nested hierarchical fashion in a manner, and that helps facilitate. For example, you have the bullets, then you have the summary, then you have the explanation of the bullets, and then you have the references and diagrams if needed. And of course there are online exams also to practice to know what you have learned, and the system also identifies the weaknesses, and the system tracks your progress, so you know what you have covered, what you have not covered. And of course it is uh, beneficial, and it has been optimized to work on small devices also like smartphones, their alignment and everything. So this is all explained in these 6 videos, and these videos are available at this URL, or you can go to YouTube and type my name, Dr. Hassan Abdullah, and it will take you to my official YouTube channel where these videos are available. And the approach of this course is maximizing upon the question and answer based approach, which is very proactive and which is very engaging. Okay, and it promotes thinking, and of course it also capitalizes on the traditional approach where data and facts are presented. So it's the best of the both worlds, which I've explained in the previous slide. So these are the list of topics, and we can see that we are at topic number 7. Now, this topic number 7 has 20 concepts in the form of questions and answers. So, as the color coding shows, the first 5 is in 7A, the next 5 are in 7B, then the next 5 are in 7C, and the last are in 7D. And now we move on to the supplemental website, and there we will look at each of these concepts in the form of questions and answers. Primary key is, so now we'll look at what is a foreign key and give example showing enforcement of foreign key so that the concept becomes clear. So what is a foreign key? So foreign key basically enforces the referential integrity. What is meant by referential integrity? It means that the database remains consistent when certain operations are performed, and that consistency is the integrity of the database itself. And referential integrity, if you go into the literal meanings, so basically it is via the basis of the referencing. We'll talk more about it. So linking the tables. Now what happens is that in the process of normalization, the the tables are split. Why the tables are split? Because of to reduce redundancy. And reduction in redundancy basically ensures that the less data is stored, takes less space, and updates are quick. So this referential integrity basically links the tables. So that's why it's very important. Then it constraints are enforced. There can be many types of constraints. What we are looking at here right now is, say for example, a person can only be added to a department if that department exists, or a person or a customer can buy items if that person is a customer itself, right? So that is the constraints enforcement. And then are the foreign key examples which I will give you, and the things will become very clear. So foreign key basically help maintain the referential integrity. So we have two tables, and in one table, okay, we have the primary key, okay, and that primary key becomes a foreign key in another table, okay. So that's how referential integrity is maintained. For example, restrict inserting a record in a child table if the reference value does not exist in the parent table, so that child value cannot be entered, okay. Same is true for delete also. So if the relationship is there, you cannot just go and delete a table, because that will bring the database into an inconsistent state, unless of course on delete cascade is applied. And as I mentioned, that it supports normalization, okay. So by virtue of normalization, redundancy is reduced. All right, so referential integrity, if table A contains a foreign key, right, that references table B's primary key, okay, then it ensures that they match, and when they match, then insertions or deletion can take place. And of course, tables can be linked together, that I have already explained, and the details are more details are here. Now, how the constraints are enforced. Inserting a record into a child table with a foreign key value that doesn't exist in the parent table will be rejected. So that is how the constraint is enforced. So a person who is not a customer cannot place an order. A department that does not exist, a person cannot be assigned to that department, and so on. Of course, referential integrity constraint takes time, right? When there is high volume of insertions in the context of real-time data warehousing, so then we have to rethink about these things. But that is not part of this course, okay. And of course, referential integrity takes time, because if the insertion has to be made, first it has to be checked, and that checking takes time. And if there is high volume of data, then that checking can become a bottleneck also. So what would happen is that this prevents orphan records, okay, to make to be around. Orphan records means that they don't have a basis. They don't have a matching parent, so orphan records cannot exist because of the constraint enforcement. So this is a basic example. We create a table, and in that table, student ID is an integer, and that is a primary key. The name of the table is students, and the name of and there is a student has a name also, which is varchar 100. And then we create another table. That table is enrollments, and in that enrollment table, enrollment ID is an integer and is the primary key. And then there's the student ID, okay. So enrollment is the primary key, the student ID, which is an integer, and there's the course, okay. And there it is, foreign key. The student ID is a foreign key, okay, where in the enrollments table. And what it references the students table. And what it references in student table, the student underscore ID. So this is how the relationship is maintained between the courses and between the students through the enrollment table. So here is a example with reference to items. So we have these items, okay. We have these orders, and we have the customers here, orders and customers. Now in the orders table we have the items, okay, and here we have this customers table. So the customer table is, this is the customer, right? And this customer has a name, right? First name and last name and age and country. And the customer has a customer ID also. Of course, age can be repeating, but the customer ID cannot repeat. And different customers can be placing the order for the same item also, right? For example, we have this order ID, and this order ID has the product, which is paper, okay, and the customer ID 5. So customer 5 has placed the order, and of course the customer 5 can place other orders also on other items also. So here's the code. You can copy this code, right, and run it and create the students table, and you can create the enrollments table also. And if you are interested in more detail, here are some references. All right, so now we move on to some very exciting topic here, which is nested SQL queries. Because the nested SQL queries, why we need the nested queries? Because of the complexity of the query itself, because of the of what is involved in the query itself. It's not just about multiple tables, but it is about what you are looking for. So nested queries, what is the definition of nested queries? Basically, the nested query is a query which is running inside a query, and there is a hierarchy of queries. And first the innermost query runs, then the next one runs, which kind of encompasses that query, and so on. So these are the so I'll go into the details of the nested queries and why we need them, purpose and necessity. Because if we if the queries are not nested and they are kind of run in a sequential manner, and some of the queries are run uh, in a different way, so to say. I will explain all of this. So that becomes cumbersome, that becomes manual, and that is prone to errors. So whenever something is manual, it is prone to errors. So what we want to do here is to have everything coded, okay, and advantages in real world scenarios. So this Q&A and the subsequent ones, we will be looking at the nested queries. So nested queries refer to as subqueries. They are referred to as subqueries, okay. And why they are called subqueries? Because they are embedded. I'll show you a picture and it will become clear what is meant by embedded. They are embedded inside another query, and usually that nested query comes, or it's embedded in a where clause, or in a from clause, or a select clause also. So where clause, that some reference value is extracted, that is in the where clause, okay, and that is a subquery, and that extracted value, that could be a single value, that could be multiple values, that could be multiple columns also, that is used as a filter in the outside or the external query. So why we need that? To handle complex data relationships, right? And also in data analytics also. So if you are interested in data sciences and analytics, so you should be knowing all those things. So this is specifically if you want to create graphs and charts, and then you should be knowing these nested queries, so that your graphs and charts carry a lot of meaning. So for example, you may want to find employees who earn more than the average salary, okay. And of course, so average, so what you need to do is, first of all, you need to get the average salary. So that average salary come from a sub query, and then the outer query compares the salary of the employees, right? And then identifies the ones who are making more than the average salary. So this is for business logic and data modeling and analytics requirements, okay. So it has its application domain also. So now you know what is basically what is a nested query. It is a sub query, okay, and that can be, and this could be returning a single value, or returning one column with multiple rows, okay, or complete table structure, right? So this is can be very powerful also, powerful in the sense that deep drilling of the data. And what it helps enable dynamic, it enables dynamic condition driven data retrieval. Condition driven data retrieval means that Let me show you. So this is one example. So this is the nested query, okay, and this is the condition which is being created, and based upon this condition the outer query runs. This is the inner query, this is the outer query. This is the nested query, or this is the sub query. I will explain this very shortly. So they often appear within the where this we discussed. So purpose of is nested queries are also necessary in filtering operations. Okay, and stems from the complexity and dynamic nature of real world data tasks. And because of nested query, you have SQL which is powerful, which is flexible, and otherwise would require procedural programming. Remember that SQL is not procedural programming in the classical sense. So it has its own way of its own approach. So using the nested query, basically it just extends the way SQL has been envisioned to be used. Okay, so for example, in e-commerce systems, you might want to find customers who place the largest order in each region, right? So need to find out without nested query, it would require several steps and require temporary storage and require sub queries, okay? And then you compare value within the same SQL statement. How you do that? Using sub queries. So we see that it has many advantages, right? And for data analytics, right? For data analytics, create layered insights, right? Insights of the data itself. So this is the table which this is what we are working around in this series of Q&A, especially in topic number 15 also. So select the description from the student table, group by description, having count greater than 1. So we are looking at the description, and we are looking at that description such that two descriptions match, having count greater than 1. Okay, so it means that there are at least two matching descriptions. And select and get all the columns from student table where description is in. So we have the matching descriptions here, and get all the records from the student table for which the descriptions match. This is the plain English for this query. So now we have a look at a slightly difficult or more challenging code. What the following SQL code does, what this does, and what will be the output of this for the given data. So over here I will show you the given data, and then we have this query. So what will be the output of this query? Now remember that it starts from the inner query. So inner query, select major from student. Okay, major is the column which is the major as food, as in food or music, and it's listed there. From the student table, group by major. Okay, order by count, descending. So grouping by major and order by count, descending. So find the major which is the most major. That's what it's saying. And that most major is find the students who have that most major. So that's the plain English for this. So if we zoom in here, so we count the majors here. So the counting is done by the inner query. So from this is the input, we can see that food 1, 2, 3, 4. So the food occurs 4 times, and music occurs twice, and then math occurs twice also, and so on. So as per the query, the most occurring major is food. So find out the students, display the students whose major is food. So this is the answer. All right. So this is fairly straightforward. and what the following SQL code does, what will be the output for the given data. Okay, so let's look at it. So select description from student. Okay, group by description having count. So this is the one, the query which I showed you before. This is the same query, right? And we see that the description here matches. They have the same description, right? So this we've already discussed. And then this one is more comprehensive. For the given data set, write an SQL query to do the following. Now, this needs to be done. Find a student whose description contains the word sausage. Okay. So there might be multiple students who have the word sausage in their description. That's point one. Then is get that student's first name. Okay. Get the first name of the student. Find their SID, student ID, and get the major of that student. All right. And then use that measure, return all students who share that measure. So one has to be like look at it very carefully before writing the query. So let's look at it query. So we go from inside out, right? So the query which lies inside the innermost query is select first name from student where description like percentage, this course percentage and percentage sausage. So what it is saying is that find the first name of the student. Okay, select the first name of the student, right? Whose description contains sausage, and limit 1. Find the first value, the very first value. All right. Then that first value, right? So you get the description. Then select student ID. Now get that student ID. Okay, you get the student ID, and then you get the major of that student, and then you get all the students who have that major. So this is the innermost query. All right, and we see that the person's first name is like probably is hello, and there are a couple of students who have a sausage in their description, but we are looking at the first record, so we just look at the first record. And then is you need to get get the student ID, and from the student ID, right, then you get the major of the student here, and then from the major, which is food, get all the students who have that major. So let's look at the query here. So this is the given data set. This is the given data set. Now we look for sausage. So sausage is not here, near, not here. Here, yeah, here we have a sausage. And sausage, the first name is hello and the last name is bye. And the second record this which has a sausage also, as there's one more, but the limit was 1. There was no offset, the limit was 1. So we pick this student ID number 30, and this student ID number 30 has the major of food. So we list all the students who have this major food, and this is the answer which we get. So this is how it works, and that's all for topic 7D. Thank you.